Okay, welcome everybody. This is the third class of Linux and Electronics at Raspberry Pi course. Today we're gonna be seeing and learning about Bash scripting and Python scripting, a little bit of Python scripting. We're gonna look at Bash first. That's going to be our main thing today. And yeah, so today I'm gonna be working from VNC, as we saw in the first class. I connected myself with, as you all know, I connected myself with looking for the IP on the Windows command line, connecting through Nmap. Here's my Raspberry Pi, and then I connected through the IP through VNC Viewer, having already all the settings here on the Raspberry Pi configurations and interfaces, having SSH and VNC all set up. So today we're going to be doing Bash scripting. This is something that most system administrators have to do on a daily basis. This is for automating. I like to call it a process, a way for programming as operating system. This is how I like to call it. It's not technically that. So yeah. So last time we saw a little example. In the last class, we saw a little example of how to create a bash script, a little simple one. It was just 2 lines, calling the shell that we were going to be using, and using an echo command just to do the example, right? Then we proceed to run it, or give it permission, and then run it this other way, which is another way to run a command. Okay, so what is Bash? Bash is a shell program. Is as we saw in the first class, a shell is a program that basically talks to the kernel through between the person and the kernel, and it reads commands, and it gives you output that we saw in the last class, called a standard input, a standard output, a standard error. Bash stands for born again shell. That's a good thing to know. And there are other shells. There's not only one. There's shell 2. Bash, the difference between Bash and shell is that Bash is it has a couple more features. So it's just shell, but with, let's say, asteroids. There's no many difference to talk about here, but just letting you know that Bash is the standard. CSH and KSH are both other type of shells. I've only seen this used by my teacher, but I don't know which are the specific use of this. For Raspberry Pi, we're only gonna be using Bash. There's not gonna be a sudden need to use this one of these two right away. So let's see how a Bash script is structured. So everything we're going to be seeing, I'm going to be doing here in the VNC. So let's go to the command line, right? Here in the command line. So let's create, I don't know if you people can see that. I don't know. Okay, great, much better. So let's create a example script. So we see it's here and also here, here. So here's how you declare variables in Bash. You can try this on the command line, and also you can do them on the script. We're gonna do that. It's a good practice to put the variables on caps. That's something you need to know. So let me do this. So let's use Nano to edit the script. And let's do what we always have to do, which is declare, which is the shell that is going to be running on. Give me a second. Okay, here. Let's declare the variable here. Let me change my keyboard. Let me put Pablo here. Oops. And let's say echo name. This is how you call the variable back. This is what when you're using another program and you want to use a variable that you store or you are storing, let's say, you call it by putting a $sign on in the beginning of it. So let's write this. Yes, enter, and let's run it. Oh yes, it's because we don't have permissions. As you can see here, we don't have permission to execute it. So let's do that. Now, this is the way I look for commands that I just typed, pressing the arrows up and down. So I now press one up, and this is the one that I just did. Press another one, and this is the other one I did. So here, I just run my program, my bash script, and give me this, which was the variable that I put here. So let's continue. This is another example. A good thing you guys want to do today is looking on each link that I have below, and if you're interested, because each source that I put here is really good and maybe even necessary. So this way of declaring a variable is doing a command, and the output is going to be storing the variable. So if you remember this command, pwd, which it gives you where you are, the root path of where you are, you can just change here. And let's change, how do I call this command? Let's do this. Save it. And let's run it. So what it did was that it ran the command at the when the variable was declared. So if it goes one by one, did this first and then it stored it, and then it went down and did the echo. That's what just happened. This is a way for you to, in case you need to know, for example, this is a good practice to do it. And if you're doing some script that you need to be sure that you have X version of your program running in your computer. So let's say Python v, oh wait, oops, let me go back. Let me open up again. Okay. Okay, so let's do another. Yeah, let's do date. Okay, so if I want to save the date, oh, I'm not in the desktop here, and then non script. I can just do this. Here. There you go. And if, as we saw, there are more programs that you can use to cut whatever information you want, and you can parse it as whatever you want. This is really cool. I've done programs to let me know how much storage I have left in my computer when I was running Ubuntu on my main computer, and I even did notifications on Ubuntu, which has their own its own program to do notifications. So yeah. So functions. This is how you declare a function. You just put a name on it, and a good practice is to use underscore for spaces, and then you just when you want to call it, you just put the name of it. This is not the only way to do it, but let's do this example here. Let's just do it right here, right? Oh, we can do this. So here, I'm going to put the name. I'm going to put the parentheses. I'm going to put here, and then date. Yes. No, let's just run date. Right now, let me cancel this here. Okay. Right now, this is not being used, but let's run it anyways. Let's see if it works. Okay, it didn't. Let's see if this way it works. No, it didn't. Okay, so let's use the example. Oh, right. Forgot. I was doing an echo to the thing. There you go. So there's the way that they're showing you here that you can do it is just is to put it inside of a string that you're going to call. But as you can see here, I did call the function just by putting the name of it. Okay, so have that in mind. So conditionals. This is a good way to make a program to be to know when things are happening. If you're doing a backup and you want to, if you want to see that there's a file that exists, and if it's not, then it should run the program again because there's an error. So this way is a way so you can do an if and with an else if. Notice, and I really like this about bash scripting, that the end of it is just the if or whatever you're using at the end, but at backwards. So if you want to declare at if, then you need to put it to put it backwards at the end. So what can we do? What can we do? What can we check? Let's see what programs do we have. Let's do. Okay, we're gonna see the conditionals in a bit once we see how we can what this commodines means, what these conditionals means. So you can compare on these conditionals. You can use equal for to test if those two strings are equal. These two strings can be variables where you have store. For example, if you run the date at one point and you have, for example, older date saved in a variable, and then you have a new date to see that you run every time you run the program, and you see that both are the same, it means that it shouldn't run the program again because you just did, right? Because you have an old, the same date and the new date, both the same date. If they are not equal, you can do whatever else you want to do. Here, there's another type of conditional, which is really fun because it's really easy to see. This means less than. This means less than or equal, greater than, and greater than equal or equal. This is another. This is other type of conditionals, which is you can just look for a file, for example, and see if it exists, if it's a directory, file, an executable, if it oh, I put 2 times if it exists, and if they are the same file. So I wanted to see this before I wanted you to see this before I did the program, because now we can use it in our program, right? So let's use this example. So let's do exist, and let's do am I here .txt. So I can just do this. Here. So let's test this. Let's debug a bit. We can just do this. If it just sits there, it's probably because it's not the path. Home, pi, desktop. Okay. Let's see if it runs. Huh. This is interesting. Okay, we're gonna look at it in a bit. You can do comments. You can do comments. Here you can do comments. One lines are here, and multiple lines are with these single ones. Okay. Oops. Okay, for some reason, the multiple line. Okay. Okay, so this is the fun part. This is where you want to do cool programs, and that even takes that they are being as if there were commands. So let's create another another program, input test. Let's call it input sh. Let's do let's put the permissions to run it. Okay, so as every time we declare that is going to run the bash here. So let's do a program that enter H. Let's do a program to see if you can enter to a library, right? So read, and let's put the name, the H. H of person. Okay. So let's see if H of person is is greater than 5. No, it's greater than 5. Library. Do our thing. And we should test if this works. Let's put 4. And if we put 10, there you go. Oh, I did a really big typo. Library. So this way you can do let's see if it works. The less or no, greater or equal, I think it was. I think I didn't. Okay, let me check that. Okay, I did that right. Okay, so I did this a couple of times, and I think it's something about the syntax. We're gonna look at that in the end, so don't worry about it. So we just did a program that you can check that the age of a person that you enter. You can also do as we saw. You can, instead of doing this, you can just put I'm going to put it in a comment here. For example, if there's a table with all of the the ages per person, you can just do the cat, let's call the age database file. Then you pipe that into grep. Let's look for the name. Let's call the kid George. And then you know the age is on the third column, for example. As we saw in the last time, there's like a little command, which is something around like this. It's not like this, but it's something like this. So what you can do is, once you have that program that is one, if you press enter, you're gonna get the age, just the age. You can just do as we did before, age or age of person equal here and here. So this is going to run the command. It's going to give the result as an input for this this variable. So the only way is not just reading by the command line, but you can just find it in another file. For example, if you are on a server, or you can just scrap it from the internet. So yeah, those are a couple of ways to do it. So arguments. This is another way that you can do, is that this is a way to make a program more to look like a to look like a command. So what you want to do is, let's call this age. Let's delete this, right? So let's call this the same age of person equal 1. So once you run the command with the next argument on it, which is going to be this one, that's the input is going to take as an argument. So if we do let's do as they say it, right? Bash input, and let's do 5. Oh wait, I did this wrong. I think I did this wrong. There you go. So as you can see, I can pass many arguments, and I can make it, for example, to look for instead of numbers, to look for letters, and then you're gonna be able to make a command like ls that it waits for an L or some other letter. There are good practices, and there are good examples on the internet if you want to look for it, and it's a good way to make a program. So let's do Crontab. This is Crontab. It's a process which is in Linux is called daemon, spelled this way, that run continuously, and it's only going to run the program when it at a given time that you specify it. Here we have a couple of Crontab commands. This Raspberry Pi has a program that I put in that it runs on the each time it boots. So here we're going to create a new one, so be aware of that. If you want to see here we have the commands, we're going to see each one of them. Crontab E is for edit and creating a Crontab. Crontab E actually opens you up the file that has all the cron tabs available. When you boot up your Raspberry Pi, or when you start using your Raspberry Pi, this should be, these lines shouldn't be in, because it should be blank. I have this one, and I'm going to explain it in a bit. But for the time being, let's do the other commands. So crontab/l, which is just like if we were doing a cat, just reading the file. If you want to remove it, I'm not gonna do that. And if you want to see the last time, oh yeah, these commands, some of them are version sensitive. For example, if you are on a this command probably works on Ubuntu, but it doesn't work here. So Crontab, this is Crontab parameters. This is how you specify when a Crontab task is going to run. So this first character means the minute. This is the hour. This is the day. This is the month. And this is the day of the week or weekday. And the command to be executed. You can use you're gonna be using numbers, and you're gonna be using a specials. Oh, I just repeated it. You're gonna be using a special characters, which are these ones. As you can see, there's one called at reboot, which means at boot, which I'm using right here. Here at boot. So each time the Raspberry Pi boots, this program is going to be executed. These other special characters means something else, and we're gonna see here. If you want a program to be run, for example, at every minute of every hour of every day of every month of every day of the week, we just need to do this. Just put 5 and then the command to be executed. Here. And as we cannot see this running, because it's going to be run on not this terminal, once we save it, it's going to be run on a terminal that doesn't have an instance like this window. It's going to be running each time, each minute, each of each hour, of each day, of each month, of each day of the week. If you want to change that, for example, I wanted to be run every 15 minutes. So we're gonna use this / 15 minutes, right? Of every 2 hours. I mean, every 15 minutes, or of every 2 hours. This is a way to, every 2 hours is going to be run. This means it's going to be in the minute 0, by the way. If I put a number, this just means that it's going to run every 2 hours and the minute 15. So have that in mind. If I want a range, I can just use 15, 30, which means it's going to be run on each minute from 15 to the 30 minutes of every 2 hours. So it's going to be, for example, let's say 0, or let's say 12 a.m. It's going to be run on the minute 15, 16, 17 until 30, and then it's going to be 1 hour, which is going to be 1 a.m. and it's not going to run. And then the other hour, which is going to run again on 15, 17, 16, and so on and so forth. You can also use, if you want specific times, you can also use, what was the comma? It was a comma, right? Yeah, it was a comma. So you just do a comma, just put 20, 10, 20, 30. So this program is going to run this program, right? This command. Again, if you want to do a program, you just need to do what we are writing out how to do, which is put Python 3 or bash or, and then you put the path, which is going to be home, pi, desktop, and then you can put test.py, for example, and this or sh. Okay, so you need to be careful with the name because you're not gonna be able to do tab to autocomplete, and because this is a file, this is not this is not in the shell, this is a file, so it doesn't autocomplete. So yeah, so if this program is going to run on the minutes 15, 20, 30 of every 2 hours of every day of the year, of every day of every day of every month, of every day of the week. So have that in mind. You can also do this with letters, which is more a little bit more simpler. You can do this if you want something to happen at some point weekly, then you just do that. You may be asking at what time is going to be running at. For that, yeah, let's go back. For that, I have a good tool that I put down here, which is Crontab Guru. You can go with me here, Crontab Guru. This is a really great tool if you want to like test what's the best time for you. So here, let's do every 5 minutes, every 5th minute of the past hours 5. And if you want to do, let's say, what we were doing here, okay, so you can do also, I don't know if you can put it here. Yeah, weekly. So yes, it's going to be run at 000 on Sunday. This is the default setting that it has for weekly. If we look for monthly, yeah, 000 of every day 1st of the month. So yeah, this is a really good tool, and I suggest you to use it. I always use it before putting it on my Crontab/e. So yeah, have that in mind. So let's do a test. And let's do a test where we run a program to make a file each time that every minute. So we don't have to stay here every day. So let's put here, right? Okay, there you go. So let's put 5 asterisks, which means every day, I mean every minute, every hour of every day of the month, of every week, every day of the week. Okay. Here, if you're confused, you can also use this. A day of the month, right? Month, every month of every day of the week, every day of the month. So let's do create a in home pi desktop. Remember, you cannot have typos here. If that happens, then the command is going to run anyways, but it's going to give you an error, and it's not going to show it. It's only going to show it in a log that the cron has, or if you want, as we show you how to do on the second class, which was how to output the error of a command into a file. You can also do that here. So that home desktop pi desktop, yeah, Crontab, just exe. So yes, enter. So let's wait. I think, I don't, it's probably, let's see if it works. Let me show you what, meanwhile, this command, which means watch. Which is for to see when something is happening. Let me use this. Oh, here, it works. So it just made it. I'm going to delete it, move to trash. Yes, and then we're gonna wait till the other one happen. And so this command is for watching every 1 second. Here, maybe here. So this is every second. This is oh wait, I'm sorry. Okay, so what I just did was a command to run every second this command. So if I want to see if something happened here, I can just do that command, and I'm going to see when this changes. As you saw, the Crontab file was generated, and then it appeared right here. So I can just go to Ctrl E. If I want to save a Crontab, you don't have to delete it. You just make it a comment, and then we are not going to have that program run in a bit, or whenever you initiate it again. This is what this Crontab is something you can use for, again, if you're doing a computer program to be run every time the Raspberry Pi boots up, you put it at boot. If you have backups that need to be done, for example, most people, I don't know if most people, but I've seen that people with Raspberry Pi projects do, they put a Crontab to zip a couple of files and folders and directories, and then move them up to the cloud. That is something that you can do. I've done it with Mega. They have their own API, or I don't remember if I used a third party, but it's really cool. So yeah. Okay, so Python script. We're gonna see a little bonus for this Python script. This and the other subjects are going to be bonus because we're going to see this in more depth in the next class. But Python script is we're going to see how to make a simple Python script on Raspberry Pi to control the GPIO. So here we have something that is really important, which is the numbering declaration, which the GPIO, if you don't know, or you have a couple of pins which are color golden on the Raspberry Pi, which is where you connect things that you want, the electronics that you want to interface with. So there are two types or two ways to call each one of these pins, which are GPIO.board and GPIO.BCM. GPIO.board is the board, the Raspberry Pi scheme is a numbered scheme that they went with and they created. But the BMC is the Broadcom chip specific pin numbers, which is when you're in electronics, each microcontroller or single board computer has a processor or a microcontroller. The microcontroller per se has pin numbers. So the Broadcom processor that they're using, where they are connecting the pins to, those pins have their own numbers. So whichever you want to use, you're feel free to use it. This is this is what the pin numbers to both of them look. Here is the board, in the middle. As you can see, 1, 2, 3, 4, 5. It's just number as it goes down. But for the BMC, you're using these ones, GPIO 14, for example, or 17 instead of 11. So yeah, if you want to do a program, you can do it right now. We're gonna there's something missing here. We're gonna see it in the next slide. But what you're gonna do is import the GPIO library, which is gonna be in the other slide. You're gonna set the mode, for example, to BCM, and then you're gonna set up the pin 18 as an output. There's we're gonna look that into more detail in the next class, and you put it high, which means there's going to be a positive if you measure it, positive output on the GPIO. So the 18 pin of the BMC is going to be this one. If we wanted to do it on the board number, which it would probably be 12. So have that in mind. So this is the script bonus, which is going to be a blinky using an LED from your kits. First of all, we're gonna see that here the LEDs, if in case you don't know, have a polarity, which means that they only can be used one way. You cannot connect it in the other way because it's either not going to work or probably going to burn. Not with this kind of current, by the way, but I mean, if you're doing a special application, it's probably going just to shut down and never turn again. That's what I mean by burn, by the way. So this is a way to connect using your breadboard. I'm going to explain because the breadboard seems a little scary at first because you don't know what each of those holes mean. So here, each line here are connected. So this is like basically a wire. All of these lines, as you can see here and here, is like a cable. So this is connected. And on the sides, depending on the type of breadboard that you have, you probably have in the middle cutoff. So for example, here, if you connect something here on this pin and something, let's use this. Here on this pin and here on this pin is going to look like, it's going to use like a cable. These are typically used for voltage. So you can put here in the red one, the positive voltage, either the 5 volts or the 3.3 volts that you're using. And here the ground or the negative. But you're not required to use. This is just to make your life easier. But in case you run out, just in case you run out of this, you can use these ones. And what I was saying was that some breadboards come with this cut in the middle. So you can connect something here and something here, and it's not going to be on a cable until you connect it in the middle, okay? And until you jump it. So yeah. So you're going to identify which is going to be the smaller, it's going to be the longer pin of the LED, but I want you to put the LED in front of between you and a lamp, so you can see these two parts. The little one is the anode, which is the positive pin. If you're going to, for example, turn this LED on by sending negative, then the positive should be connected right on top of here. For example, you're going to be connecting here on the 5 volts. We're going to see that in case you didn't understand it. We're going to see that in more detail in the next class. So yeah, so here's the example program that I was telling you about. This is a Python program. So what you need to do, I'm going to do it here with you, in case you're doing it with me, right? In the case, okay, so let's create a program, a file called blinky.py. We're going to give it the permission to be executed. There you go. So we do ls l, and we're going to see that Blinky has executing permissions, right? So let's enter. By the way, you can also use, if you're using the Raspberry Pi GUI, right? You can also use here this IDE, which is basically a specialized, if you don't know what an IDE is, it's basically a text, it's a notepad or it's a text reader, but with asteroids. So it's going to help you to develop in X or Y language. This one is specifically for Python. So we're going to see Blinky, right? Let me see because I have it. Okay, there you go. Okay. So yeah, I'm going to import the Raspberry Pi GPIO as GPIO. So what I'm doing here, I'm going to explain this briefly. Here is where you call the library. This library is basically a program that helps you to talk to whatever you need or do whatever you need to do. This is just basically compact programs that you call for your use on this program. So I'm just, when I use as GPIO, I mean that whenever I'm going to call this, I'm going to call it like this. So for example, instead of doing Raspberry Pi like this, Raspberry Pi GPIO, instead of doing this, dot again, set warnings. False. Instead of doing this, I can just do GPIO dot set warnings. False, right? There you go. So that's what I'm doing right here. You can just change the name. It doesn't need to be either. You can just do, for example, let's call it sun. And then you can just call it like that. This is case sensitive, by the way. As you can see, that even the I of the Raspberry Pi is case sensitive. So from the library time, I'm going to import sleep, which is going to help us to do the timing for the blinking. So here I set the first line, which is set the warnings off. If you have it on in your whenever you're running the program, is going to give you a couple of warnings. So you just set them off for the time being. GPIO set mode. So GPIO board. Let's use the board one. Then use GPIO setup. Oops. Setup. 8. GPIO out. And then you can even put the initial state like that. Well, for you to understand it better, so you don't have like too many things in that statement, I just do GPIO dot output, and then I just set it manually low. So there. If you save this program and you run it, yeah, it's just going to run, and it's going to go and set that pin off, and then the program is just going to stop. So in order to do the blinky, we need to do something called a function in order for it to run like forever, which is while. Is while true? Missing space. And then we can do, okay, so let's turn this pin on. And let's sleep for 1 second. This is something that, this is like, we call this in the programming of hardware, we call this a delay. This is something that when you're doing timing things, it's just you're telling the CPU of your computer, which is running really fast a couple of times, many times per second. You're just doing don't do nothing for a second and wait for the next command. So the next command is going to be this one, we're just gonna set here. So now if I save this and run it, then it's just going to be forever here and doing the on and off. I want you to try that, to connect it to the pin number 8, which is going to be on the board, to be this one, or the 14th in the BMC. I want you to try that and let me know how does it works. The result should be something like this. It should be turning on and off. So yeah, that's it for the class of today.